Okay, so we're going to state the transformations, and then we're going to create a table for this and a graph. So we have y equals 2x squared. Okay, so the only transformation is this 2. And remember, if you have a 2 out front, it's either going to be a vertical stretch or vertical shrink. Because this 2 is greater than 1, it's going to be a vertical shrink by, or sorry, vertical stretch by 2. Okay, so vertical stretch by 2 because this 2 right here is bigger than 1. So that's the only transformation that we have to work with here. So where we're going to start with, the parent graph. So in other words, the graph without any transformations is that just the x squared. So y equals x squared. So we're going to make a table with values of the parent graph, y equals x squared. So for most of these graphs, for my x values, I use -2, -1, 0, 1, 2. Usually that gives you a pretty good indication of what the graph's going to look like. So if we do -2 squared, that'll give us a y value of +4. -1 squared will give us 1. 0 squared will give us 0. 1 squared will give us 1. 2 squared will give us 4. Okay, so to make our next graph, we said that we have a vertical stretch by 2. Okay, so to turn this into y equals 2x squared, when we have a vertical stretch by 2, we are going to multiply the y value by 2. So think about if it's stretching, it's stretching this way. So that's why we're multiplying the y value by 2. Okay, so anytime you have a vertical stretch, you're multiplying the y value by whatever the number is. So we're going to keep those x values exactly like they are, but all the y values are going to get multiplied by 2. So 4 times 2 will give us 8, 1 times 2 will give us 2, 0 times 2 is 0, 1 times 2 is 2, 4 times 2 is 8. And then because that was the only transformation, now this table right here is what we're going to graph. So we're just going to plot the points. -2, 8. It goes off the graph a little here, but -2, 8. And then we have -1, 2, 0, 0, 1, 2, and then +2, 8. And remember, quadratics have this U shape, so it still has the U shape. But instead of being the normal quadratic shape, it has been stretched, vertically stretched up. So we have that there. Okay? So the next one we're going to look at is going to look very similar. But now this 2 is in the inside of the parentheses. So if it is on the inside, it's still going to be a stretch or a shrink, but it's going to be horizontal. And you have to be careful. So this is going to be horizontal because it's on the inside. Okay, so remember this number here, you're really looking at its reciprocal. So really thinking about, instead of 2, 1/2. So since 1/2 is less than 1, it's a vertical shrink by 1/2. Okay, so let me say it again. Because this is in the parentheses, it's horizontal. When it's in the parentheses, you're really looking at what the reciprocal does here. The reciprocal of this would be 1/2. Because that's less than 1 is going to be a shrink. Okay, so our parent graph is still going to be y equals x squared, so the quadratic. So we're going to make our original table. So I'm going to use the same numbers as last time. So if you just plug in the x squared, you'll get 4, 1, 0, 1, 4. Okay, so to get to our next table for y equals 2x, and the whole thing is squared, because we said it's a horizontal shrink by 1/2, when you're doing things horizontally, you're working with the x value. So we're going to multiply the x value by that 1/2. Okay, so vertical, you're multiplying the y, but when you're going horizontal, you're multiplying the x. So when we multiply -2 times a half, that'll give us -1. -1 times a half will give us -1/2. 0 times a half will give us 0. 1 times a half, 1/2. 2 times a half will be 1. The y values are not going to change. You're just going to copy those down. And then because that was our only transformation, then we're just going to graph that. So we're going to have the point -1, 4. -1/2, 1. 0, 0. 1/2, 1. And over 1/4. So still quadratic, but this time we shrunk horizontally instead of stretching vertically. Okay. So then our next one, we're going to be looking at a different parent function here. So we have 2 absolute value of x plus 1 minus 3. Now we have a lot more transformations going on here, so we're going to have to make more charts. So we're going to just talk about the transformation parts first. So because we have this 2 and it's out front, that means it's going to be either a vertical, shrink, or stretch. So it's going to be vertical and it's going to be a stretch because that 2 is bigger than 1. Great, and then we have x plus 1. Remember when it's on the inside, it's either going to be left or right, but you have to think about the opposite. So because it's plus 1, it's going to be left 1. And then this -3 is on the outside, it's -3, so it's going to be down 3. So those are our 3 transformations that we're going to have. Okay. So we're going to start out with our parent graph. And this time our parent graph is y equals the absolute value of x. Okay, so we're going to make our chart. I'm still going to use the same x values, -2, -1, 0, 1, and 2. So remember, absolute value just means the positive of it. So absolute value of -2 will be +2, +1, and then these will just stay the same. Okay, so from our directions on what you have to do first, so you're going to make sure that we always do the shrink and stretches first, then it's reflections, then it's shifts. So we're going to do shrink and stretches first. We're going to do this vertical stretch by 2. So because we have this vertical stretch by 2, when we make this, we're really going to make this be 2 absolute value of x. That's the part we're going to do first. So vertical stretch by 2, because it's vertical, we're going to multiply the y. So we're going to multiply y value by 2. And we'll make our new chart. So we're going to keep the x values exactly like they are. But we're going to multiply the y's by 2. So we're going to end up with 4, 2, 0, 2, and 4. Okay, so next, left 1 and down 3, those are both just shifts. So you can do them in any order you want to. So I'm going to do the left one first. So when I do this, I'm going to now have to print this absolute value of x plus 1. So if I want to move left 1, so moving left is messing with your x value. So since we're moving left, you're going to subtract 1 from x. Okay, so we're making a new chart. This time you're subtracting 1 from all of your x values. So -2 minus 1 will give us -3, -2, -1, 0, 1. Your y values are going to stay exactly like they were from the last chart. Alright, so one chart left to go. So for the last one, we are moving down 3. So down 3 affects your y value, so you're going to subtract 3 from y. And this will give us our final thing with all the transformations. Alright. So we're subtracting 3. So the x's are going to stay exactly the same. We're going to subtract 3 from y. So 4 minus 3 will give us 1. 2 minus 3, -1. And -3, -1, and 1. Because we've now finished all of our transformations, then we can plot these points. So we're going to have -3, 1, -2, -1, negative 1, negative 3, 0, negative 1, and 1, 1. So remember, absolute value graphs have a V shape. So you're going to have your graph with your V shape there. So that was 3 transformations. Just make sure you always start out with shrink and stretches first.